Hey everyone! So we are going to continue our quadratics unit that we are doing. So just because we took a quiz doesn't mean like we're on to a new unit. We are still talking about quadratics. We just wrapped up just sort of understanding quadratics and multiplying binomials. And what this is going to talk about, we're going to start the process of sort of undoing that multiplication, and it's called factoring. So make sure you are following along, taking notes, writing down any questions you have, and as usual, I really encourage you after I do like an example or two to pause the video and try it out on your own to see how you're understanding it. If you're getting them right, that's awesome. If you're not, that's totally okay. Just keep chugging along and listening, and writing everything down and writing down questions if you have any. So, and in true Rosaki fashion, I recorded about half of this and then realized my mic wasn't on. So, I'm going to do it again because that's just where I'm at these days. So we're going to talk about factoring, and this is just the first part of factoring. There's a lot of factoring we're going to do this year because it is like the most important skill that you're going to learn in Algebra 2. The skill is used in every algebra-based math course that follows this one. We do it in pre-calc, calculus, any higher level math. So it's really important to understand how to do it. If you had me freshman year, then we did this at the end of the year, your freshman year, but it's okay if you don't remember it. If you had Mr. Gestazio or Mr. Zucca or Mr. Hill, you probably saw it too, but odds are we did it way at the end of the year. It was the last thing we did. We did it really quick. So if you don't remember it, it's okay. If you do, awesome. But we're just going to go through it. So factor has two different meanings. Factor can be a verb and factor can be a noun. So the verb of factor refers to rewriting a quantity as an equivalent product. And really what that means is rewriting an expression as an equivalent multiplication problem, right? So it basically means taking something like 6 and writing it as 3 times 2. So we get deeper into that, but that's essentially what it means. And then factor, the noun, is any individual component of the product. So like, for example, the factors of 6 are 3 and 2, right? Because it's the individual components of the product. So just kind of keep that in mind. That's like a simple way to think about it. So we're going to factor expressions that have variables and stuff like that, but we're going to start off with just factoring numbers. So what this says is factor each of the following integers completely. And really what that means is write them as a product of only prime numbers, which is called prime factorization. And you can use a factor tree, which is what I like to use. If you don't like the factor tree, you don't have to. So the way we think of this is we want to think of any two numbers that multiply to 12 besides 12 and 1. So my brain goes to 6 and 2. If your brain went to 4 and 3, you will end up at the same answer. So 2 is prime, so that's good. 6 is not. 6 can be broken down further to 3 and 2, which are now both prime. So the prime factorization of 12 is some combination of 3 times 2 times 2. And if you have a different order, it's okay. It's multiplication order doesn't really matter. So that is your prime factorization. So for 30, we can go 5 and 6, you can go 3 and 10, 2 and 15, and you will still end up at the same answer. 5 is prime, 6 is not. 3 and 2 are both prime, so 30's prime factorization is some combination of 5 times 3 times 2. 16, I'm going to go 4 and 4. Those are not prime, so I can break them down further. 2 is prime. So 16 is 2 times 2 times 2 times 2. And last but not least, 36. I'm going to go 6 and 6, which are both not prime. We can go 3 times 2 and 3 times 2. All of those are prime. So the prime factorization of 36 is 3 times 2, 3 times 2. Again, if you have it in a different order, no problem. So always keep in mind that when we factor a quantity, we're simply rewriting it, and I cannot stress this enough. You want to have equal things on each side. So like I mentioned before, 2 times 3 looks a little different, but it's still 6. It has the same quantity, and if I multiply them together, I end up at the same place. And that's the goal when we factor binomials as well. Actually, when we factor anything, we want to make sure that they're equivalent statements. It's really, really important, because if they're not, then it doesn't make any sense. So it says rewrite each of the following binomials as a product of an integer with a different binomial. So really what that means is they want you to end up with a number times some sort of binomial. So you could have a plus in here or a minus, and that'll just matter on what the original started with and what we factored out. But that's what they essentially want. So here I have 5x plus 10. And the first thing I need to do is figure out what the common factor is. Like, what number can I remove from 5 and 10 without getting a fraction, right? So the common factor here is 5, because I can divide 5 and 10 evenly by 5 without getting a decimal or a fraction. That's really important when we factor no decimals or fractions, only whole numbers. So we're going to look at this and say 5x plus 10 is going to become 5 times some binomial. And I need to figure out what this binomial is going to be made up of. So the way we figure that out is we say the common factor times something has to get me back to the first term, right? That's the goal here, right? We want this to be the product of 5 times whatever here. So 5 times what is 5x? 5 times x is 5x. And then we do the same for the second term, because we want what's here to be the product of 5 and this. So we say 5 times something equals 10. Something is 2, it's a positive 2, so we write plus 2. It's kind of hard to see. So this is plus 2, because 5 times 2 would get me back to 10. And this is our factored form of the expression. So factored form, sometimes they'll ask you like, what's the factored form? So this is it. And we can check our work. The best way to check our work is to distribute. If you factored correctly, you will end up back where you started, because they're equivalent statements. So if I start at 5x plus 10 and I say that's equal to 5 times x plus 2, I should be able to prove it by distributing this out. 5 times x is 5x, 5 times 2, positive 10, and we're good to go. Both sides match. If they didn't match, you would have to just check your work to see where you made a mistake. So I encourage you right now to pause the video and give B, C, and D a try. If you want to watch B first and then try C and D, that's fine as well, but I really want you to try these on your own and see how you do. So the common factor between 2 and 6 is 2. Right, I can't divide those by anything else evenly, so they both divide by 2 evenly, so that's my common factor. So I'm going to end up with 2 times some binomial, right? And then we want to figure out what are the blanks of the binomial. So we say the common factor times something should get me 2x, right? Because this times this should leave me here. So x. And then the common factor times something should get me negative 6. And that's going to be negative 3. And the sign is important. So make sure it's x minus 3. So negative 6, because 2 times negative 3 should get me that, and it does. So again, that's factored form. You can check your work by distributing. I'm not going to. C, the common factor here is 3. That is the largest number that 6 and 15 divide by, evenly, so no fractions or decimals. So 6x plus 15 is going to turn into 3 times some binomial. And again, we need to figure out what the blanks of that binomial are going to be. So we do the common factor times something is going to get me 6x, right? 3 times whatever here should equal the first term. So 3 times 2x will get me 6x. And then 3 times something should get me 15 because of this. So my something is going to be 5, and it's positive, so I need to put the plus. So you have to put plus, or else there's no point. You need to make sure you're putting the sign there. And that is our factored form. You factored the expression to be 3 times 2x plus 5. And then the last one here, D, the common factor is 2. That's the largest number I can divide 6 and negative 14 by evenly. So we're going to have 6 minus 14x equals 2 times some binomial. I need to fill in the binomial. So we should have 2 times something getting me to 6. And that something is 3. And then 2 times something should get me negative 14x. And that something is going to be negative 7x, so minus 7x. And that is factored form. So those are examples where the common factor is just a number, and that's about as simple as it can get. We are going to now look at examples where the common factor can be both a number and a variable as a monomial. So we're going to see that on the next page. If you need to take a second to write this down, if you weren't already, make sure you pause the video and copy it down. All right, so it says, the above type of factoring is often referred to as factoring out the greatest common factor, or what's known as the GCF. I will almost always call greatest common factor GCF. You'll hear me say it all the time. I'll be like, what's the GCF? Take out the GCF, factor out the GCF. So make sure you do that. This greatest common factor can be made up of numbers, variables, or some combination of both. And we're going to see that in these examples. So when factoring out our greatest common factor, we want to ask ourselves a few questions to help us figure it out what it is. So the first question we ask ourselves is, what is the greatest number that I can divide all my coefficients by evenly? We remember, no fractions, no decimals. That's what we just did in the previous problems. We have an additional question to then ask ourselves. Now we need to see if there's a common variable in every term. If there is, then we ask what the lowest exponent is, because that's going to be our GCF. So if there's an x in every term, then x is going to be our part of our GCF. So it says put the coefficient GCF and the variable GCF together as a monomial to create your overall GCF. And again, that will make more sense as we do some examples. So let's go into the first one. So it says write each of the following binomials as a product of the binomial's GCF and another binomial. So really what that means is it wants GCF times binomial, which is what we were doing before, but now our GCF might have a variable in it. And I say might because it's not going to every time. So 3x squared plus 6x. So we ask ourselves, the first thing we ask ourselves, what's the greatest common factor, or what's the GCF of 3 and 6? The answer to that is 3. Right? So I can divide 3 by 3 and 6 by 3 both evenly. That's the largest number they have in common. Cool. So then what's the GCF of x squared and x, because both of these terms have a variable. If they didn't, then we would not include this part. So what's the greatest common factor of x squared and x? The greatest is just x. That's the most that they have in common is 1x. So the total GCF is 3x. So it's those put together as a monomial. And now I'm going to figure out what my factored form is now that I know my GCF. So I'm going to have my original expression is going to turn into 3x times some binomial. And we're going to find out what the binomial is the same way we did before. Right? We're going to say the GCF times something must get us to our first term, right? Because 3x times something, we should end up at 3x squared. So the something here is going to be x, right? 3x times x, 3x squared. We also need to figure out 3x times what will get me 6x. So 3x times something should equal 6x. 3x times 2 will get me 6x, so this is going to be plus 2. And that is my factored form. I have fully factored that binomial. This is factored form. And again, to check, you can distribute. So if I distribute this, I do end up 3x times x is 3x squared, and 3x times 2 is 6x. So I know I'm correct. I think you should pause it and try B. Don't try C just yet because C is a little different, but definitely try B. So for B, if you want to write it out, you can fully write it out like I did in A, but I'm going to notice that the greatest common factor is 5x. It's 5x because they each have at least an x in it, and then it's 5 because the highest number that can divide 5 and 20 is 5. So I'm going to have the original. And it's going to be equal to the GCF times some binomial. I need more space. I wrote that way too big. It's going to be equal to the GCF times some binomial. And I want to figure out what is my binomial going to be. So I'm going to say the GCF times something should get me 20x. That something should be 4. And then again, the GCF times something should give me 5x squared. Oops, negative 5x squared it should give me. That negative is important. Make this a little smaller. That didn't do anything. Technical difficulties. Give me a moment. There we go. All right, so we said we want the GCF times something to get me negative 5x squared. So the something is going to be minus x. So that is my factored form. 5x times 4 minus x. And you could check that if you wanted to. I'm not going to, but this is factored form. So what's special about C is that my first term is negative in C, and that's like really annoying. We hate negative x squared. It just like is really gross when we're doing math. So anytime the first term is positive, this is the first term, when the first term is negative and we're factoring, we're going to include the negative in the GCF. So we want to factor out the negative as well. We don't like it, so we're going to keep it as part of the GCF. So what's the greatest common factor between negative 10 and negative 25? It is negative 5, right? Because we're going to take out that negative. And then the GCF of x squared and x is x. So my total GCF is going to be negative 5x. So I'm going to have negative 10x squared minus 25x equals negative 5x times a binomial. So we're going to ask ourselves negative 5x times something equals negative 10x squared. So that something is going to be 2x. And then also ask ourselves the GCF times something is negative 25x. So that something is going to be 5. And that is our factored form. Negative 5x times the quantity 2x plus 5. And then, like I said, pause and try D now. Really, the goal is to be able to just go to look at this here and be able to just come up with this without doing any of the above stuff, right? This is the goal, is to just look at it and know what factored form is going to be, but it takes practice. So if you need to write the above stuff, write the above stuff. So in D, we need to be careful. This term has no x. So there's going to be no variable in the GCF. You can't take it out if it doesn't exist. Right? So it doesn't exist in both terms, so there's no variable as part of the GCF. So the greatest common factor here, remember we want to think of the biggest number that divides 30 and 20 is 10, not 5. So we're going to say 10 times, oops, let's change the color. So 10 times something needs to get me 30x squared. And then 10 times something needs to get me negative 20. So we've got question mark equals 3x squared. And this one, question mark equals negative 2. So I'm going to end up with 30x squared minus 20 comes out to be the GCF, which is 10, times 3x squared minus 2. And that is factored form here. Again, take it all in, write it all down, pause if you need to, and give 4 a try. So in exercise 4, it really is just asking you the same thing, it's just multiple choice, but I want you kind of to ignore the answers and just factor. Oh, I don't know why we went all the way back to the beginning. So we have 20x squared minus 36x. My greatest common factor here is 4x. There's an x in both, and both of those are divisible by 4. So I'm going to have 4x times, and this is really how I want you to do it. I know that 4x times 5x is going to get me 20x squared, and 4x times 9, negative 9, is going to get me negative 36x. But if you have to, write it out. There's nothing wrong with writing it out. So it's going to be choice C. And if you actually looked at your answer choices, choice C is the only one with a GCF of 4x, so it could be the only answer. Okay, we're almost done. We just need to factor some trinomials. So I can also take GCFs out of trinomials. It's the same process. There's just 3 terms instead of 2. So in the end, you're going to have like GCF times 3 terms instead of 2. So it says factor out the GCF of each trinomial. Whenever you're asked to factor, it means write your answer as the product of the factors. So I want you to try these. You might want to watch the first one and then try the rest. So in the first one, there's no x here, so in the last term, so no variable in GCF. So the GCF here is just going to be a number, and the highest number that divides 2, 8, and 10 is just 2. So we're going to be at eventually 2x squared minus 8x plus 10 is going to turn into 2 times some trinomial. And now I want to figure out what the blanks of my trinomial are going to be. So 2 times something has to get me 2x squared. That something is x squared. Then 2 times something has to equal negative 8x. So that something is negative 4x. And then last but not least, 2 times something has to get me 10. The something is 5, so plus 5. And there you have factored form. 2 times the quantity x squared minus 4x plus 5. And trinomials, they can be factored further. Some of them, that's something we will talk about in the next couple of lessons. Like we're going to practice GCF and then something else and then get to that. But we are going to learn how to factor those. So B, again, no variable here, so no variable in GCF. So the GCF, the largest number that can divide all of those is 5. So I'm going to say 5 times something. Actually, let's work on my colors here. So 10x squared minus 20x plus 5 is going to end up being 5 times some trinomial. So we're going to have 5 times something equals 10x squared. Something is 2x squared. 5 times something is negative 20x. Something is negative 4x. And then 5 times something is equal to 5. So the something must be 1, so plus 1. And that's factored form. If you don't believe me, you can distribute it out and see that it matches. All right, 2 more and then we are done. I'm sorry that this might be a little long, but I just wanted to make sure that you really understand this skill. So for this example, notice that the first term is negative, right? We don't like when our first term is negative, so we're going to include a negative in the GCF because the first term is negative. Also, the GCF is going to have a variable because all 3 terms have a variable. So, with that being said, the greatest common factor here is going to be negative. And then the largest number that divides 8, 12, and 20 is 4. And then they all share an x. The smallest exponent with the x is 1, so it's just going to be negative 4x. So now we want to figure out the GCF times what gets me negative 8x to the third. So to make x to the third, I'm going to have an x squared. And then negative 4 times something is negative 8. Negative 4 times 2 is negative 8. So 2x squared. Then I need to figure out negative 4x times something equals 12x squared. So to make x squared, I know I'm going to need just an x, and then to make negative 4 a positive 12, I multiply it by negative 3. So negative 3x. And then last, we have negative 4x times something is negative 20x. So in this case, the question mark is just a 5. So we're going to go from negative 8x cubed plus 12x squared minus 20x to the first to negative 4x times all of this lovely stuff that we just came up with. Just 2x squared minus 3x plus 5. And the last one, D. So it's very similar to C, there's just no negative. So the GCF is going to be, the greatest common factor is 3x. That's the largest number that can divide all 3, and then there is an x in each term. So we're going to have 3x times some trinomial to end up at the same, right, the equivalent statement. So we want 3x times something to get me 6x cubed. That's going to be 2x squared. And then 3x, right, the GCF times something has to equal 15x squared. So that's going to be 5x. So plus 5x. And then the last one here, the GCF times something has to equal negative 21x. So the something is going to be negative 7. And that is factored form. So that's how we factor a GCF from binomials and trinomials. If you have questions, let me know. Please make sure to submit your notes to Google Classroom so you can get full credit for the assignment. Thanks, everyone.